Velkommen til igen. Welcome back. Please turn off iPhones and other stuff. So, good to see you again. Just to make sure, this is the statistics class, not computer science or anything else, programming. Okay, we have a nice and tight, exciting plan this morning. We have to get on with our statistics course, and we have to do a bit of probability today to be good at looking at numbers, but we'll all get back to that. Let me begin, as I promised in my little message to you, with a little recap of what we did last time. Also, since my survey data thing broke down on me on the 30 seconds I had last time, so let's have a look at how real data analysis hits you when you get out in real life out there in a few years from now. Actually, typically, when people ask you to help you, they will send you a data set, and typically it will be some weirdly looking Excel sheet. For instance, like this, which is all the data that you gave to me, and whoa, it looks, there's a this is very difficult, not impossible, but difficult to sort of read directly into R. Remember, at the end I asked you to give me your heights, right? So let's analyze those heights, and this is the column. Please write your heights in centimeters. Let me just do a bit of data cleaning. That's always the start. In real life situations, for the projects in this course, we sort of helped you out a little bit. So this is the first step of data cleaning, right? Now I came a bit. So nice, we had, let me see, 152 playing around with me here. Thank you for that. What I do is I just take the data into another data sheet, such that I have a single column, hopefully of nice data that I can import in R. I'm still not quite done with the data cleaning. Typically you get odd data, erroneous observations, and funny people around. Lab technicians having dropped something on the floor without telling the boss and things like that. I apologize if I didn't see you, but I think I would have seen you. If you're here, please wave your hands and prove it. Sorry about that. I think that's a mistake, okay? Of course, this is the difficult part of data analysis. This is the data cleaning. This is also where you have to be careful about the ethics about what you do, because you may actually suddenly throw away something that should not have been thrown away. Let me just run through and see what happens to me down. Oh, there's a guy who was friendly enough to put the CM in there. That would mess things up completely when I asked R to read this with the CM, so I removed the CM. Let me see what happens more down there. There's an empty guy there. That would probably be okay, but let me just... then there's a little thing actually. I have to choose one, either the dot or the comma. I mean, either one could work, but let me just take the comma there, and let's see what happens. Very precise. Let's see what happens down there. Of course, if I had 1 million observations, this would take a bit of time. And there could be other ways. Yeah, funny enough. We have 2 guys of exactly that height. Oh, here's a funny guy also there. Thank you for helping me in my stuff here. Let's delete this guy also. Let's delete the empty guy there, and I think I'm more or less done, hopefully. Let's try to save that one. I saved that one. Like this. Actually, what we usually show you and do, there are different ways of doing these things, of course. Here is a kind of a nice and safe way. Let's save the Excel sheets as CSV, comma-separated files. That's a nice way to have it, yeah. It's not the only way, but it's a nice way. And I save it as heights. Now I'm not going to do it because maybe I did a mistake in this rapid thing, because I did this already an hour ago, right? So I save this in the heights data set. That's fine. I did that. Then I go into R. Let's remove that one. Go away. Go away. Go away. Let me find. I brought the mouse. Should use that. I jump into R, and I share this with you also. Let's read in this data into R in a single read table, the heights. Use, as a decimal point, use the comma. As the separator between columns, use the semicolon. There's only one column here, that's easy. Is there a header in the first line? No, there's not in these data. These are the three options you need to think about when you read in data. If you think about these three options, you can basically read in anything. And if you're in doubt, look at your data file and see which are the right options. Fantastic. Maybe it couldn't find the file. Maybe I should just make sure that I have the right working directory. I use usually this one. I set working directory to source file, which means I take the place where I have my R file. Look at that, set working directory, blah, 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 blah. That's where I have my week 1 stuff lying on my computer. The heights data set is there in that folder. So now hopefully my read will work. Yes, it worked. Then we had 140 heights. What is the histogram? Now, this is what I taught you last time now. The first stuff is just practical stuff that will hit you when you have to do this in the real life. It will also hit you when you do projects, when you go to in the future. Now we can start doing the stats. What is the story about the heights? Well, it's a pretty right skewed. It's not completely symmetrical, it appears. The summary statistics I taught you is telling you a story about the data you have, right? That's the way you should use them. What about the box plot? I told you that. Well, our heights goes from 140 centimeters up to 204, I remember. The 140 guy or female seems to be considering a slightly outlier in the general context. Sorry for saying that if you're here, but I think you would know, of course, if you are. That's a fact of life, I know. The middle box is from, let's go summary. Here's the summary from 141 up to 204. The median is 180 centimeters. That's the typical height when I sampled you. The first and the third quartiles are 170 and 185. So the middle 50% of all data is within this range of 15 centimeters. That's the IQR, the interquartile range. That's 15 centimeters. All of these are stories that I could sit down and tell about this data by looking a bit on the histogram box plot and the summaries. I used these basic summary statistics to tell the story about what's going on. That's how we should think of those statistics, and that's how you should get started with your project also in this when you have to work with your project. Good. That's it for recapping last time. Any questions on that part? Then let's get moving with today's topic. Random variables, discrete distributions, probability, suddenly. Throwing a dice, throwing a coin, that's the kind of situation that we will spend the 2 by 45 minutes